So, you've decided to become a professional chemist. It took many years of hard work, copying from people smarter than you, wondering what you're doing with your life, but you finally have a degree and a powerful arsenal of chemical skills at your disposal.
But what do you do now? What industry do you go into? There are many possibilities, some more lucrative than the other.
We've most likely all heard the slogan sex sells, but probably thought it would never be used in context of chemist or chemistry. In fact, in some ways the two are complete polar opposites.
But there is a huge demand for chemists in the industry of sex, specifically in the chemical field of polymers. Now you might still be confused, but all will be explained as we discuss the polymers of the adult market.
The adult market is huge, making an estimated £40 billion worldwide every year. This is hardly surprising as most people have sex. Now, even though some would like to see copulation as purely a means of conception, a very large proportion of the market is dedicated to contraception, bringing us to our first market niche, condoms. Yep, these fellas have been around for as long as 360 years, but the polymers needed to create these condoms need special properties, including the ability to stretch, be water insoluble, and difficult to tear. At first, manufacturers used natural rubber for rubbers. You might know this to be called latex.
Latex, which is first extracted from trees as a milky, sticky substance, is an emulsion of sugars, starches, gums, proteins and alkaloids, but most importantly has a high concentration of polyisoprene in it. This can form a natural rubber which can be moulded, is stretchy and is very difficult to tear.
Now, this polymer is brilliant for condoms and is still primarily used to this day, but there is an issue with this. You see, about 1% of the population are allergic to latex, with symptoms ranging from a runny nose to an aggressive sore rash, which, let's be honest, might have a slight drawback on the libido. For these few, a new polymer was needed with similar properties. The alternative polymer chosen was polyurethane, and for a very good reason. It is reasonably easy to produce a polyurethane polymer which has long chains and very little cross-linking. The long chain helps keep the polymer strong and difficult to tear, whilst the lack of cross-linking keeps it stretchy. All in all, this has suitable properties and is the second most used polymer in the production of condoms.
Polyurethane is produced via the reaction of an isocyanate group and an alcohol. Unlike other polymerizations, there is no real initiation step, only a rearrangement of the isocyanate and alcohol to form a urethane group, hence polyurethane. Usually this is catalyzed via tertiary amine.
Now we've covered condoms, but this is only the tip of the iceberg. Perhaps another industry you might be interested in is lubrication. With up to 60% of people requiring lube in their lifetimes, it's yet another huge industry.
Perhaps the words polymer and lube seem like two very different things to you. But polymers are at the heart of what makes lubricants work. Let's start with water-based lubricants.
Lubricants are polymers surrounded by smaller individual molecules known as plasticizers. In the example I'm giving, the plasticizer is water. The smaller water molecules will stop the polymer strands from touching each other, expanding the polymer structure, which can now move more freely. On the macroscopic level, this now appears as a gloopy, slippery mixture, which is very good at lubrication. The most popular lubricants usually contain the polymer hydroxyethyl cellulose. This is modified cellulose found from cotton, for example, which has had its R group swapped for a form of alcohol. When mixed with water or glycerol, the alcohol groups hydrogen bond to the smaller molecules of water, expanding the cellulose structure into a lubricant. But different lubes are needed for different people. Another popular polymer used in lubricants is dimethicone. Dimethicone is one of the first polymers we've encountered which doesn't have a carbon backbone. It's formed via the reaction of dimethyl dichlorosilane and water and has some interesting properties. The flexible backbone of the polymer on top of the methyl side group allows for a very liquidy, oil-like feel. The polymer is also very hydrophobic, meaning it can trap moisture into the skin and thus is found in more high-end cosmetics. But perhaps this isn't what you're interested in at all. Perhaps a more general industry which might interest you is that of clothing, in which case you'd be investigating polymers for materials. In this sector, you may be asked to develop a polymer for lingerie, more niche clothing, and materials which are meant to look like other materials, for example, leather. Chemistry has already provided good alternatives to silk tights by providing the world with the polymer nylon. This is produced via step growth polymerization. The reaction occurs between the end groups of 1,6-diaminohexane and 1,6-dicarboxylic acid. This condensation reaction will produce long chains of alternating amide molecules, which puts light on the other name for these polymers, polyamides. Another material I mentioned was that of leather, which can be mimicked using the plastic PVC or polyvinyl chloride. The reaction starts with vinyl chloride, a haloalkene, and grows into a polymer via free radical polymerization. New polymers for clothing are being investigated all the time, and new polymers with special properties will be discovered in the future. What I've been referring to as the adult market is so huge that it could be split into hundreds of individual markets. And I think this is my point for making this video. Even though something like sex seems totally unacademic, when a subject like chemistry is applied in the correct way, it reveals so many improvements which we can make. From something basic, like a barrier contraceptive and lubricants, to more individual tastes such as lingerie, it is important to recognize the futility of attempting to innovate a part of your everyday life without understanding the absolute fundamentals of what you're dealing with, which in these and most cases are molecules. I hope that you enjoyed this video, and thank you for watching.